Okay, example 4 says segment O to P lies on a real number line with point O at -9 and point P at 3. So they're just assigning some numbers for some points, just like the ruler postulate lets us do. Where is the midpoint of the segment is what they want to know. Where is the midpoint of the segment? So I'm not going to draw the whole thing like you have there, or that you saw on the previous screen. What I'm going to do is go like this, okay? And I'm going to put some coordinates on there, and I'm going to say this is -9, this is 3, and this is O and P. And they want to know where the midpoint is right there. And you can call it whatever you like. A lot of people use M. Well, one of the ways to do that is just to find the average of the two numbers. So -9 plus 3 divided by 2 equals what? -6 divided by 2, which is -3. So this would be -3 there. And that it turns out to be the same distance from -9, as it is from 3. They're both 6 units apart. So that kind of it was quite easy, but there's a second part. It says, what if you change the endpoints of the segment O to P to x1 and x2, so the first x and the second x. So we've got to make some changes here, so I'm going to do that right now. Let's erase this, and we'll erase this. Okay, and I'm going to write some more stuff below in red. So we change this to x1 and this to x2. Okay, we still want this midpoint right here. We still want that midpoint. And so how do we do it? Well, last time I did the average of the numbers. Why don't I do the average of these two numbers instead, but I'm going to call them x's. So I'm going to rewrite that below. If I wanted the average of two numbers that I don't know, and they're both x's, I'd add them up and divide by 2. This is an average of two numbers, and it would give you the midpoint for any situation that involved some kind of horizontal change between x's on the number line.